this is lab 2 for Comp 380. This lab deals with informed search, in particular the A-star search algorithm. So here are some preliminary questions. So the difference between uninformed and informed search is, as suggested by their name, the fact that informed search is able to use additional information, such as a given node's proximity to the goal, whereas uninformed search only is able to incorporate node positions and arc costs into its searching strategy. And heuristic is generally what we call that extra information given to the algorithm. And in our particular case, the heuristic is going to be the estimate of the distance from a node to the goal. And heuristic, in order for it to be admissible, the function must always be an underestimate of the true cost, which means that the value of the heuristic must be less than or equal to the true cost of getting from that node to the goal. Question 2 gives us this graph and asks to determine the arc costs. The only arc cost that is given is this 2. These other ones I have filled out. That is pretty easy to calculate. All you have to do is you take this f of n, subtract the heuristic value from it, and then the difference between these two has to be the cost of getting from the start to that node. Right, so for node C, you could see that the f of n is 3, heuristic is 1, so the cost from A to C has to be 2. And for example, for node F, you could see that f of n is 5, and the heuristic is 2, which means that the cost from A to F has to be 3. So you have 2 here, and this one has to be 1. Yeah. Question 3 asks, is the heuristic admissible for this graph? And for this question, we are, as instructed by the professor, going to ignore the direction of the graph. So we're going to assume that each path is can be taken forward and backward in order to calculate the heuristic for nodes B, D, and F. Given that assumption, the heuristic values are admissible, as shown in this table. You can see that for each node, the heuristic value is either less than or equal to the actual cost to get from node N to the goal. And the last question is asking to represent this program in AI space, incorporating the heuristic values and all the arc costs. Make a prediction and then solve it. So these are my predictions. Actually, I could just pull it up here. So there's the graph, and my prediction as you start at node A, nodes B and C are added to the frontier. As the f of n value of C is higher, the algorithm will move to node C. Node B is removed from the frontier. And then from C, node E and F are added to the frontier. E has a lower f of n, so the algorithm will move to E, and E happens to be the goal node, so the algorithm ends. We can actually verify that over here. Go to A star. You can see that B and C are added to frontier. C has the lower f of n. Then E and F are added. E and F are added to the frontier, and E is the goal. So there you go. The algorithm will exit out. And that's it. Thank you.